He's one of the hosts of a podcast I listen to, and I reached out to him. The podcast is Ham Radio Workbench, and it's one of two podcasts that I definitely listen to every week, or at least when they have it out. They're not actually a weekly podcast, but close to it sometimes.
Fortnightly, every 2 weeks.
Yeah, and it's a mow your lawn, as they like to say. So they'll go on and on depending on how big your lawn you have.
Hello.
But no, there's a lot of good info. There's a lot of smart guys on there that have been doing this for a long time, and they love building things and sharing what they do. So I encourage everybody to search up the Ham Radio Work sometime.
John, and just as your Zoom controller, I'd like to request a couple of things. If everybody would go on mute except for Mark and stay on mute unless you have a question, that would be greatly appreciated because it'll keep the extraneous noise and stuff down. And I am not going to record this because he has an excellent presentation on YouTube. So I think we're good to go there in that respect.
Okay, it sounds good. Yeah, if we could do that, everybody go on mute. And Mark, I'm assuming you're going to need to be able to share.
Yeah. The cringe I'm making right now is that I just made the mistake of initiating a bulk download of a bunch of books I just bought, and it is opening every single PDF in a new tab. And no matter what I do with my browser, it just keeps popping up a new tab, and I can't minimize it. Anyway, like I think I can do this without a browser. So yeah, please allow me to share my screen. Okay. Present as slideshow. There we are. Okay. Share screen. Oh, of course you're not going to do it. Zoom has this thing about sometimes it does and sometimes it doesn't let me share my screen. Okay, we're going to have to do this one the old-fashioned way, just verbally. Yeah, because Zoom is not cooperating with me. Okay, but that's okay. First off, my name is Mark Smith. Hi. N6MTS is my call sign. Formerly KR6ZY for many, many years. So if you ever worked KR6ZY or recognize that call sign, that's me. I decided I didn't want to try and identify as crazy anymore and joined the Initials as Call Sign Club a few years ago. So N6MTS. As said earlier, I am a host of the Ham Radio Workbench Podcast, your bi-weekly deep dive into technical topics of interest to the radio amateur. If I can get our byline out of my mouth correctly. And I've been a ham for 30 years or so. Is that right? Yeah, 92. Since 92. And I spent the first 20-ish years of my career, 25 years, I guess, as doing IT work. So network engineering, systems engineering, and information security. But about 2 years ago, I left that career and started my own company doing electronics. Electronics have been a hobby of mine since I was a young kid. But kind of the combination of doing software development for so long and electronics as a hobby and being an amateur radio operator, when I got burnt out on information security and decided I wanted to try something new, I started Halibut Electronics. So to answer the obvious question that people are probably asking but are too polite to verbalize, where the heck did Halibut come from? So Halibut was actually the name of my first BBS back in the late 80s. It was Just for the Hell of It BBS. And my mom looked at me and she's like, "You're 12 years old. How about we go with Just for the Halibut BBS?" I'm like, okay, fine. So I ran Just for the Halibut BBS for a number of years, and it eventually just got shortened to the Halibut BBS. Then 1995 came around, and I finally got on the internet, and I had my own domain name, and halibut.com was available. This was before the big land grab happened in the late 90s. So I've had halibut.com ever since 1995, but I've been Halibut as an identity, kind of a personal identity, since the late 80s. So whenever I start a business, it's usually halibut this or halibut that. This is my third official business using the halibut brand. So here we are, Halibut Electronics. All right, so what are we talking about today? We're about the Open Headset Interconnect Standard. And I really wish I could share my screen. And no, I cannot. Okay, so we'll just do this verbally. Go through all of that. All right, so let's look at each of these words. Open Headset Interconnect Standard. What do these mean? Open, meaning that it is an open standard. To borrow a term from software, it is free like speech, right? Free software, the open software, open source movement, the open standard. It is a standard that is published. It is, the standard itself is public domain, and it is usable by anyone without having to pay royalties or anything like that, right? It is an attempt at getting everybody on the same page. Headset. This standard describes the connection between the radio and the user. Things like microphone, headphone or speaker, and PTT. I summarized those as a headset. It doesn't technically need to be a headset, but that's kind of the most common use case. So I will use the word headset in a lot of places, but be aware that headset can be just like a standard microphone and some good quality headphones and a handheld PTT if you want. But for reasons of brevity, we just call it headset. Interconnect, meaning that I want to be able to connect my headset to your radio without having to worry about an adapter that is unique to that headset and the radio. We'll get into that in a second. And then standard, meaning that if everyone abides by this standard, reads the document and implements things according to the documentation, your headset should work on my radio, even if we've built these ourselves, right? So that's the whole point of a standard. So Open Headset Interconnect Standard. So what is the problem that we're trying to solve? That's kind of the first thing that we should be asking. In ham radio, we have a number of standards already, right? Some are de facto, some are defined, but things like RF, right? As a standard for RF, we've got 50 ohm coax. Pretty much every radio, with a few exceptions, use 50 ohm coax. Kind of one of the exceptions is, 450 ohm twin lead, but you got the balanced and the unbalanced. Electrically, they're very similar. They're very easy to convert back and forth between. And I don't need to have a feed line that is unique to my brand of radio. At the worst, I might need a connector that is different than my brand of radio has, but since the electrical standard is the same, it's easy to get adapters that convert back and forth between those. Similarly, for power, we have 13.8 volts as an electrical standard, 13.8 volts plus or minus 15%, right? And again, we might have different connectors for that. Anderson power pole is a very common connector, but on the back of HF rigs, they've got that 6-pin, looks like a Molex, but isn't really a Molex connector. Or on mobile rigs, they've got that T-shaped blade connector. But again, because it's the same electrical standard, it's very easy to convert back and forth between the physical standards. We don't have a standard like this for the interface between the radio and the user, right? If you look at any given radio, they will use different physical connectors for their microphone. And even when they have the same connector, there'll be a different pinout. And then in some cases, even if they had the same pinout, it's a different type of microphone. So I can't just make an adapter that takes this pin and routes it to that pin because the microphones are incompatible, right? There are so many different ways of doing things, and every radio manufacturer does them differently. Do you use a dynamic microphone or an electret microphone? Is your microphone balanced or is it single-ended? Audio out of the radio, is it headphone level, is it line level, or is it speaker level? And if it's speaker level, is it ground referenced or is it push-pull? You can't plug a push-pull speaker output into something that's expecting a ground referenced signal. You'll blow up the hardware, right? So these are like fundamentally incompatible signals that you can make circuits that will convert between the two, but it's a pain in the butt. You can't just take one thing out of one radio and plug it into another, right? There's so many to choose from. And the physical connectors, right? Is it a 3.5 millimeter microphone connector, or is it the 8-pin round connector that's popular on a bunch of HF rigs? That's called a GX16, by the way. Everyone just calls it the 8-pin round connector, but its technical term, if you're trying to find it, one to buy, is a GX16. Ask me how I know. Or is it an RJ45, right? There are all these different physical connectors. And again, even if it's the same physical connector, they have different pinouts. And then sometimes, even if you have the right adapter, electrically, your microphones won't work, right? You can't plug an electret microphone into a radio expecting a dynamic, or vice versa, right? I have a lot of slides that have pretty pictures that demonstrate this, but we're going to skip past all of those slides and go straight into how do we address this. So what I am proposing is the Open Headset Interconnect Standard, as I have said many, many, many times. Is there someone who can share their screen and bring up a web page for me? Because there's a diagram here that I really want to have on screen while I'm describing this.
Sure, go ahead. I'll do that.
Oh, okay. You want to do it, John?
Sure.
Okay.
What's the website?
Oh, sorry, ohis.org. And then there should be a PDF linked there to the presentation that I'm looking at right now, actually. Oh, shoot. No, I don't have that. Oh, for Pete's sake. Click on the GitHub repo.
Okay.
And go to Docs.
Okay.
And then the one that has my name and call sign in it. This should be the presentation. Oh, this is an older version of it, but it'll work. Download that and then open it up. Oh shoot. You know what? That might not actually work. Hang on, John. Let me email it to you. I'm sorry.
Okay. Yeah, I just sent you an email on your support address.
n3ak.john at?
Yep.
Okay. I'm really sorry about this, folks. Where did it go? It's in here. It's in there.
Mark, we're hams. We're used to changing shit on the fly, so don't apologize.
Right. Yeah. All right, John, I just sent you the email with the slides.
Just arrived.
Okay. So what? When you get there, go to slide 42. Huh. Didn't even put that together. So the diagram that he's going to show you is going to be a summary of what an OHIS compliant system looks like, and then we'll go into all of that. So, who am I? Okay, yeah, just fast forward. There we go. All right, so this is a diagram that shows what an OHIS compliant system looks like. So the idea being that if we have this standard in the middle, it allows any device on the left to be able to talk to any device on the right. Go to the next slide. Nope, the other way. There we go. So on the left, we have what are called user devices. These are things like headsets, microphones, and speakers, and PTTs, and whatnot. In an ideal world, device manufacturers would adopt OHIS natively, and we would just have headsets with OHIS ports on them directly. That's what you see at the top. That's an OHIS compliant headset. I realize that we are a long ways away from getting the hardware manufacturers to adopt this natively. So we are going to have to work with adapters in the meantime. And so we're going to have these user adapters that are going to take whatever the headset has, whatever kind of microphone, whatever kind of headphones, whatever requirements your headset has, and it's going to turn that into this standard interface, right? And again, it doesn't have to be a headset. It could be an individual microphone and a powered speaker and a PTT button, right? As long the signals that are the important part. And it's going to turn it into the standard interface. Next slide. And then similarly, we're going to build an adapter that goes with the radio side. And it's going to convert whatever that radio has, whether it's a dynamic or an electret or expects, whether it's a headphone output or a speaker output or whatever it is, it's going to take all of that and convert that to the standard. And that adapter is specific to that radio, and it stays with that radio. I should have said that about the headsets. The headset adapter is specific to that headset, and it stays with that headset. Next slide. And then OHIS is the connection in between them. So the idea being that now that we have these adapters on the headsets and an adapter that goes on the radio, now they all use standard interfaces. And I can now take my personal headphones and plug them in to any OHIS compliant radio without having to worry about whether I have the adapter that is. I should have gone through all of the slides. I'm sorry, I skipped a part. The whole point is that in our current situation, all your headsets have different interfaces and all your radios have different interfaces. And so to get this headset to work with this radio, you need an adapter that is specific to the pairing of that headset to that radio. And if I want to use this headset on another radio, I need to have it a second adapter that is specific to the pairing of that headset to that second radio. And then if I want to make a headset, I've got to have two more adapters that work between that headset, that second headset, and both of the radios. And you end up with this full mesh of adapters between all the different headset options and all the different radio options. It's an end-to-end or an n-squared mapping of all of these adapters that you need to be able to make a situation like that work. Whereas with OHIS, I make one adapter for my headset and it stays with that headset, and that's the last adapter I ever need for that headset. I make one adapter for my radio and it stays with that radio, and it is the last adapter I ever need to make for that radio. If I add another radio to my shack, I make one adapter for that radio, and that's it. Doesn't matter how many headsets I have. All right, so let me go forward. Okay, before I go on and talk about what the actual standard is, does that part make sense? Are there any questions about that before I move on? Hearing none. Let me talk a little bit about where these are useful. When you look at this and you say, well, that's still a bunch of adapters. How is that better than using adapters that are specific between the headset and the radio? Again, it's in your personal shack at home, it doesn't make a lot of sense. I'll be perfectly honest with you, because you've got one, maybe two headsets, and you've got 1, 2, 3, 4 radios, and that full mesh isn't all that big. And chances are you like a particular type of radio, and so you may have multiples of the same brand, and so the same adapter will work with those different radios. So that's not the environment for OHIS that it really shines. Where it shines, where it's really useful, is in multi-user environments, right? Think of a club shack where you might have a couple of different radios, but you've got a whole lot of people that come in and want to use that shack. Or a contesting station where you, again, have maybe just a few radios or a number of radios and a lot of different people that want to be able to use those radios. I don't know about you, but I don't like other people using my headset because my headset has my ear goobers in it, and I don't want you getting your ear goobers into my headset. Similarly, I don't want to wear your ear goobery headset onto my head, right? So I want to bring my headset into an environment and be able to use it at any radio that I sit down at. So like a contesting station for a field day event, or an EOC is another common environment where this would be very useful. Again, you don't know where you're going to be stationed at the EOC. You bring in your own headset, and you should be prepared to sit down at any radio and work any of the stations that you need. And you can't do that if you don't have the right adapters. So OHIS really shines in that kind of multi-user environment. Okay, so let's talk a little bit about what the standard is. Can you go ahead and go to the next slide and go one more? So first, we're going to talk about what the electrical standard is. The microphone standard I've chosen is electret level, and there are some technical reasons why I chose that over dynamic. I won't go into them here. If you're curious, hit me up afterwards and we can go into details. Next, the audio input level is headphone level. So it is capable of driving headphones, but not necessarily capable of driving a speaker. But that can also be used as a headphone output, can also be used as a line level output. Next, the PTT is a simple contact closure to ground. Next, and then I think we talk about power. Yes, the OHIS radio side provides 5 volts worth of power at 200 milliamps, provided by the radio toward the user side if the user side needs power for anything. Then we'll talk about what kind of adapter this makes. Next slide. The physical standard is a 8P8C modular, commonly referred to as an RJ45. Technically, that's incorrect, but I've kind of given up on that fight. The RJ45 connector, like an Ethernet connector, is the connector that all of this goes over. Go to the next one. Unsurprisingly, the cable is shielded Cat5 cable. Next. The wiring is TIA 568A or 568B. If that doesn't mean anything to you, don't worry about it. Don't like tune out the rest of this presentation thinking it's too technical, because go to the next one. All of this means that you can use common off-the-shelf pre-made Ethernet cables. That's the standard was designed specifically so that cables are very easy to come by. You don't have to make your own cable. You can just buy them off the shelf. If you want to make your own cables, you're welcome to. Crimp tools aren't that expensive. All the parts are there. If you're a network nerd at all, you probably already have some of the RJ45 crimp tools. I certainly do, but I'm also nerdier than most. But if you don't want to make your own cables, you can buy common, inexpensive, off-the-shelf shielded Ethernet cables. All right, next slide. So on the user side, the headset side, so over on the right, we show what the RJ45 socket and what the different signals are on the different pins. You don't have to internalize any of that. The important part is that if you have a conventional headset that is just headphones and an electret microphone, we'll get into dynamic in a second, an electret microphone and a simple switch, like a push button for PTT, then your user side adapter has no electronics. It is just wires. You're just connecting the correct pins on the RJ45 to the correct pins on your headset. That makes it super simple to wire up a headset into this standard. If it's an electret microphone, there is no circuitry whatsoever. It's just wires. Next slide. If you have a headset with a dynamic microphone, looking at you, Heil fans, I'm one myself. Heil makes great headsets, makes great microphones, but he has this thing about really preferring dynamic microphones, not electret. That's not a problem. It's just that dynamic microphones tend to need other things with them to work with certain radios. That's why he sells the ICOM specific elements, because ICOM won't work with with dynamic microphones. So he sells an electret microphone element that you have to swap out the microphone element on his headset to be able to use his headset with an ICOM radio. Instead of swapping out the microphone element, the way OHIS deals with this is that if you've got a dynamic microphone element, there is a preamp that you can build with 5 components: a transistor, 3 resistors, and a capacitor. That's it. And you can add that to your user adapter, and that will allow any dynamic microphone to work with the OHIS standard. Let's go to the next slide. And that's what this circuit is. This circuit is part of the standard. It is free for anyone to use. So making a user-side adapter is trivial from an electrical standpoint. It is almost exclusively a physical build project. I've got an RJ45 port on this side. I've got whatever ports my headset uses on this side. If my headset is a if my headset is electric microphone, you just have to connect the wires across. If your headset is a dynamic microphone, then these 5 components that cost pennies, you build them in this arrangement, and now your dynamic microphone works in the OHIS system, which is expecting an electric microphone. So that is all part of the standard, and it is super easy to build on the user side. This ends up putting most of the complexity on the radio side, but that's where most of the difference is anyway. Are there any questions on that side, on this part so far, before we move on? Giving people time to find their mute buttons. All right, hearing none. Next slide. So I think I've already gone over this. When is OHIS useful? When you have different radios and different headsets, multi-user environments, in example, field day, club shack, or emergency operation centers. Go forward a few more. 2 more. 1 more. There we go. So that last one there, to present a common electrical interface for devices between the user and the radio. I'm going to come back to that one because this is actually what I, as a business, want to be doing. And I'm going to come back to that one in a second. All right, let's move on to the next slide. When is OHIS overkill? When you only have 1 radio or 1 headset, or any situation where that full mesh problem I described at the beginning doesn't really apply. Next, or if you've already got all the adapters you need. And next, or if you prefer the simplicity of just having a single adapter between you and your radio. OHIS is 2 adapters, and it does kind of add some complexity to the system, but it allows for a lot of flexibility. And if you just don't need that flexibility, or if you'd prefer not to have that complexity, then OHIS may not be the right solution to for you to implement. But in these other environments, like the multi-user stuff, or if you've got a lot of different hardware that you want to be able to connect to all the different things, then OHIS is a good solution for that. Next slide. And then 2 more. So why do I want to do this as an open standard? Because closed standards, each manufacturer doing their own thing, is how we got into this mess in the first place, right? The whole point of having a standard is to get adoption, to have everyone using that standard. And you can't really convince other people to use that standard if it's a closed standard, right? If they got to pay royalties on it, that's just silly, right? And besides, this makes a great DIY project. Ham Radio Workbench, the podcast that I'm on, our goal is to get people building, or at least thinking about building, finding a problem in their life that they want to solve, and then learning the technology and the techniques and the tools they need to be able to solve those problems. And then now they have that new tool in their tool bag. Sometimes that's a literal physical tool, and sometimes that tool is a skill, a new skill set that they have that they can now apply to other things in their life and make their life better, make other people's lives better, right? So DIY is doing it yourself, right? Like club builds, right? That's the kind of thing that I want to encourage with OHIS. So y'all as a club, if you've got a shared environment with a bunch of radios and everyone has their own headsets, I would love to help you design your own user adapters and radio adapters and make it a club build project, right? All right, these are the radios we have. This is how we're going to make adapters to present a standard OHIS interface on these radios. Let's come in and, you get that one, you get that one, you get that one, and then everyone gets to build their own headset adapter. And now your multi-user club shack, you can take any headset to any radio without having to worry about any of that. If, as an alternative, you'd rather throw money at the problem and you don't want to build it yourself, there are companies out there that are making these adapters for you that you can just buy. But from a standards advocacy standpoint, I prefer to talk to everybody about, DIYs and homebrew projects and whatnot. All right, next slide. And that's the obligatory Learn More. So for OHIS, the Learn More is just ohis.org. That's where that QR code takes you. And it's just the website that has a more complete version of this presentation, because I was actually able to use my slides at the first half of it. And it has a link to the standards document itself if you want the technical details of what the standard looks like, and all that. So that's the standards advocacy side of this. If you'll allow me to get a little commercial, I'm going to take my standards advocacy hat off and put on my commercial sales guy hat. Halibut Electronics makes and sells these adapters. So from a standards advocacy standpoint, if you want to build your own, even if you want to start a company building these and competing with me, I will help you do that, because I am very interested in getting adoption. So I would love to help you build your own device if you want to do that. If you don't want to, I sell these adapters. You go to electronics.halibut.com is the webpage. Electronics.halibut.com is the webpage where I am selling my HHI, which stands for Halibut Headset Interconnect, Radio Pro, which is the radio adapter that will work with any radio if you configure it right, and the User Pro, which is the user adapter that will work with any headset if you configure it right. The User Pros come pre-configured for several different very common headset types, and the Radio Pros come pre-configured for several different very common radio connector types. But if your radio is not available on one of the pre-configurations, the documentation is there for how to configure these devices for your specific radio, if it's a unique or one that I haven't made a pre-configuration for. So you can right now go out and buy the hardware to make your shack entirely OHIS compliant without having to do any builds if you want. Those are pre-orders. I will be shipping hardware in October of this year. So that's my commercial sales pitch. Try to keep that brief. Are there any questions about Open Headset, or why the heck you should care about it, or what I just said, or any of that stuff? Anything? Any questions at all?
Yeah, I have a question and something to point out too. So for the group, three places I think this could benefit the group is one, we have a trailer with multiple radios. So adopting this would so we don't have to have one, different headsets for the different radios in there, or different plugs, so forth. Yep. Two, we have the coordinator for our Aries on here, and a lot of the Aries members for our area is on here. So that's another area that this could benefit, and because we might be in a situation where we need to, here, borrow my radio. And if we're all adopted to the standard, then you would know that your headset will work with whatever radio you borrow.
Correct.
And the others, obviously, is field day. And one of the components, and if you mentioned it, I missed it, but I like the component that you've talked about in the past, where the box that you have for the station, and you have the operator, the logger, and option for a speaker for people walking by and be able to turn things up. Did you mention that?
I have not. No, I mentioned briefly that there's a part of this slide deck that I wanted to get back to, and that's exactly what that is.
Okay.
So, but I wanted to answer any questions about the standards advocacy side of this first, if there are any. Or about just the adapters in general.
Hey, Mark. Jim here. I've got this Heil headset, and it's got, I guess you can't, so it's,
Yep.
I've got connectors like that.
Okay, those are 1/4 inch.
You have modules that would work with those type of connectors.
Okay, so move them up just a little bit. Just so I can see them on the camera. I want to see. Okay, yeah, those look like adapters. So if you take off those adapters, they are the 3.5 millimeters underneath? Correct. Okay, yes. So I have 2 different User Pro configurations for Heil. One for Heil with a dynamic microphone and one for Heil with an electric microphone. So if you use your Heil with an ICOM, you probably have one of the IC mic elements. And if you do, there is a User Pro that's configured to work with that. If you have a dynamic microphone element, there's a User Pro that's configured to work with that. If you buy the wrong one, they are very easy to reconfigure. You have to open it up and move a couple of solder blobs. It is solder blob configuration style, but it can be reconfigured for one to the other. So yes, one of my User Pros will absolutely work with that headset.
Okay, then the other question that I thought of was maybe we have some CW operators that use different keys. Is there any way we could put those keys into your interface and make them work with different radios?
So short answer is no. OHIS does not attempt to deal with CW switching. Part of the reason for that is because the CW paddles, they're all just contact closures, right? There isn't really a lot of electrical differences between the two. Now, if you wanted to have one set of paddles that works on multiple different radios and just be able to switch back and forth without having to pull a cable out of one and plug it into the other, that's a different problem that I am also attempting to solve with a commercial product. That's not part of the OHIS standard. Having said that, there has been a little bit of discussion about using the PTT line, which is currently just a simple contact closure for push-to-talk, and extending that line to be multiple different impedance levels. And if the resistance is 0, then that means PTT. So it's backward compatible. You contact close to ground, then that signals PTT. But if you contact close to ground through a 1K ohm resistor, then that's DIT. A 2K ohm resistor is DAW, right? Or something along those lines. There has been talk about trying to extend the standard to do that. That hasn't been ratified yet, and I'm not 100% sure that would solve the problem in the way that I think people want. So okay, so I guess it depends on what you're trying to accomplish with CW keys. Like, what is the use case you're trying to do with a CW key?
Just make the connectors compatible between different radios. Some of them use the smaller size like that for a key.
Where's the camera?
And others use the 1/4 inch,
the larger one. Yeah.
So I mean, that's probably not that big of a problem. I use these adapters and it works for me, but I just wondered if the interface was taking that into consideration. And I understand why you wouldn't put it in there, just because of the modularity for the microphones and the headsets. One other question is, how far back into vintage radios would you go for compatibility?
So Radio Pro, in theory, can work with literally anything. You may have to wire up your own cables. So from a connector perspective, actually, can you stop sharing the screen, John, so I can make me big again?
I'm looking for the stop sharing.
Yeah.
If I just close the window, there, that works too.
If you shared the window, then yeah, that would work. So this is what my Radio Pro device looks like, right? So on the back, there are a bunch of connectors that you use to connect to your radio. There's the GX16, the 8-pin round connector. There's an RJ45, and then there's a 3.5 millimeter. All of these are microphone connectors. You get to pick which one works with your radio. There's a separate PTT RCA adapter there that's used for flex radios. They have an external, like a PTT on a separate cable. And then a 3.5 millimeter there for a headphone. And I sell, 3.5 to 3.5 cables, and also a 3.5 to a 1/4 inch cable. So if your radio has a 1/4 inch output, you just adapt that using the correct cable, or those adapters like you were showing me, Jim. The question of whether it will work with old radios. These are the connectors that are available on my particular adapter. You might, if your radio doesn't have one of those connectors on it, you might have to make your own cable. But from an electrical standpoint, dynamic microphones and electret microphones have been the same for a century, right? They haven't really changed. Now, if you have a radio that uses a carbon equivalent mic, I think I have just barely enough gain to work with a radio that is expecting a carbon equivalent. That might be a bit of a stretch. But there are trim pots in here that you can use to adjust the level from, a carbon equivalent on the one side to a dynamic on the other side. That's roughly 50 dB worth of difference from, high microphone level output for a carbon equivalent to a low microphone output for a dynamic microphone. So there's a trim pot in here that you would use to adjust the microphone output level to accommodate for that. The speaker output from the radio, if it's only a speaker output and not headphones, we can take that. I think I can work with up to a 10-watt speaker output. I think is the number I calculated, and that's a very powerful speaker output for a radio. Most are usually around 2 watts, 3 watts, somewhere around there. So that we can definitely work with, all the way down to headphone level or even line level. We can take a line level output as well. And then the PTT is a contact closure to ground. There is a voltage and current limitation on that contact closure. The voltage limitation, I think, is 40 volts. And a current limitation, I think, is 100 milliamps or so. I would have to go look at the opto-isolator to figure out what its limitations are. So you're not going to be switching plate voltage on some of the really old radios. You'll need to put a relay in there to handle the high plate voltage of an old tube radio if it's sending that plate voltage through the PTT button. It's not going to handle that. But as long as it is a reasonable voltage going through the PTT, we can switch it. Does that answer your question?
Yeah, more than answers my question. I just wondered what backward compatibility would be.
Yeah, it should work with literally anything. The only reason I'm not making absolute statements and saying it will work with absolutely anything is because I hate being proven wrong. And I'm sure if I said it will work with anything, someone's going to come along and say, aha, I found the one unique device that it doesn't work with. So anyway.
John was right. It'd be best we could use it for our field day and for our Aries group in our trailer.
Yeah.
Great idea.
Certainly anything in the last 20 or 30 years, it'll work with. Okay. Are there any other questions, or should I move on to the contesting console, which is the thing that John was talking about? All right. I'll stick around afterwards if anyone has any more comments. Let's move on to the contesting console. So on a earlier slide, I was talking about how on the when is OHIS useful, and the statement was to present a common electrical interface for devices between the user and the radio. What the heck does that mean? So as it is right now, if I want to build a device that goes between the radio and the user, that device needs to be able to handle all that complexity about what kind of microphone level does the radio expect, what kind of microphone is on the user side, right? All of those different options needs to be handled by that device. Whereas if we abstract all that complexity out into these adapters and present a consistent interface, it now makes building devices that go between the user and the radio super easy. So this is the first of such devices that what the heck is a contesting console? It has ports for 2 users to connect their headsets. They're labeled left and right operator, but think of it as a logger and an operator. So one person is using the radio. Think of like a contest, a field day. You got one person who's on the microphone with the PTT calling CQ Field Day. This is N6MTS 2 Alpha Santa Barbara calling CQ Field Day. And then you've got another person that's listening to the radio, and whenever they hear a callback, a call sign, they write down the call sign, and then the operator and the logger look at each other and say, yep, I agree, that's the call sign we just heard. And then the operator calls back and says, N3AK, this is N6MTS, we are 2 Alpha Santa Barbara, blah, 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 blah. You got 2 people wanting to listen to the radio, and they also want to be able to talk to each other, to be able to say, I'm sorry, was that a N3 or an M, or, like a K3, whatever, right? So they need to be able to talk to each other without having to pull their headset off, be able to say, what was that you just said? And so they want to be able to have an intercom between the 2 of them, and they both want to be able to hear the radio, right? So that requirement is what started this contesting console. So what is this? We got 2 ports for operators and 1 port for radio. Each operator has their own 4-channel mixer down here. These are the 4 different inputs into this device, and they go into the headphone for that operator. This operator has their own 4-channel mixer that goes into their headphones. What are these 4 channels? The first one is the radio itself. So you can set the volume of the radio in your own headphones. The next one is your audio. So you can have your own microphone audio going into your headset, so you get a little bit of side tone, right? You want to be able to hear your own voice so you're not yelling. The next one is the other operator's microphone. So you can mix in the other operator's microphone audio so you can hear them talking as well. And then the 4th one is what I'm calling an ambient mic. There's a little MEMS microphone up here on the board, right there, that is just picking up sound around you. And so that if somebody walks up to the table and wants to talk to you, you don't have to take your headphones off. You can just turn up the ambient audio a little bit and be able to hear them as well as everything else that's going on. And so now, as an operator, I can set those 4 different volumes into my headset individually and listen to exactly what I want to listen to and ignore whatever I don't want to listen to, and still be able to talk and log and operate and do all of those things. Whichever user presses their PTT, that user's audio gets sent to the radio when that radio gets keyed up. And that way, that's why I call them left and right operator instead of logger and operator, because either one of them can operate the radio. The 2 sides are symmetric. They have identical functionality. And then the last feature on here is that there is a speaker power amplifier and a little speaker output, a 3.5 millimeter socket there, with a volume knob for the speaker itself that is taking audio from the radio. And the advantage to this is when there are people walking by at field day and they want to be able to hear the QSO, they want to be able to hear what's going on. They can already hear the operators because the operators are just talking out loud, but they can't hear the radio because the radio is going into my headset now. So with this, they can turn that volume up and plug in an external speaker here, and now they can hear both the radio and the operators. But if there's nobody listening, then you want to turn that down just so that you're not creating a whole bunch of ambient noise. Yeah, so that's the contesting console. 2 users, 1 radio is the whole point of it. The users have an intercom so they can talk to each other. The users can hear the radio, and then they can key up and send to the get audio into phones, and then turning up the speaker to get audio. The world. Radios, and I now have a volume knob for each radio going into my headset, and I can adjust the volume of every radio into my headset. My microphone gets amplified and sent to all radios, and then there's like a 4-position switch to select which radio I key up when I hit the PTT. So I know I don't have to pull a headset out of one radio and plug it into the other. All I have to do is just turn the knob, and I can be monitoring all of them. So let's say I'm, working some contests, but I also want to monitor my my local 2-meter repeater or something like that. You can have multiple audios coming into your headset. Remember how I was saying that those things don't necessarily need to be headsets? They don't necessarily need to be radios either. You can make a radio adapter that plugs into a USB port on a computer and looks like a sound card. Right? And so now I can be listening to music while I'm working, and primarily listening to music, but also monitor and stop what you're doing and go listen to that. Right? Like, all of this is possible with OHIS. All of this was a raging pain in the butt before OHIS.
Hey, Mark.
Yes.
Okay, so I equate this to the internal communication system on an aircraft where the pilot and co-pilot can talk to each other, or they push the foot switch and they're broadcasting over the HF radio or whatever. Absolutely brilliant.
Very similar, yes.
Fantastic. Love the design. How do the 2 operators talk to each other without hitting their push to talk? Are their mics hot all the time, or?
Yeah.
Okay.
In this design, their mic is hot all the time. And if you don't want to hear what the other person is saying, you can turn their volume down. Like if they start having a conversation with somebody else, and you can turn their volume down, but then you have to turn it back up again when you want to start hearing them again.
Okay.
But there isn't like a second PTT for being able to talk to the other operator.
Gotcha. Okay. That's.
Yep.
Makes sense.
Mm-hmm. I'm curious, does the airplane ICS, is it similar? Is it always a hot mic to the other person in the other seat?
No, there's actually 2 switches. There's usually a button on the yoke for talking to internal to the crew, and then there's usually a foot switch or some other push to talk switch for the HF for their off aircraft comms.
There's
Okay.
different ones. I worked on the E2 where they have 3 crew members in the back plus a pilot, co-pilot, and they have variations of select by the operators on how they wanted to operate. So they had a mode where they can it's still kind of a push to talk, but they use Vox so their voice would activate the PTT and be able to talk to each other without having to physically hit a button. Or they had the option to do a ICS PTT, and they had 2 buttons, ICS PTT and a radio PTT. And then they had different selector switches to govern how, if I push a radio PTT, which radio am I going to go out on? Like in the
Yeah.
aircraft, there's about 8 different radios that could go out on.
Nice. So that sounds like a combination between the contesting console, where you got multiple users, and the station console, where you've got multiple radios, and you got a little matrix switch to figure out what goes where. Yeah. Yeah, so contesting console, or at least the first version of it, is going to be super simple, and it's just always hot mic to your partner, and then the PTT is used to key up the radio. However, if only one user hits the PTT, the other user's microphone audio does not go out the radio. So it's not like it's always mixing the two microphones. Although, as a consequence of the way it's built, if both users hit PTT, both of their microphone audios will in fact go out the radio. But that wasn't a design goal. That's just the artifact of using an inverting mixer, an inverting amplifier, and the output of the combiner. So,
for a question on your, what would you call the other one? Multiple
the
radios.
station console.
Station console.
Yeah.
Are your thoughts on doing any? I think it's called binaural mixing, so that each radio. Say I have 4 radios, and they appear to come from different places spatially.
The first version of Station Console, my goal is to keep it. I'm adhering to KISS. Keep it simple, stupid. So the first one, I'm just doing stereo mixing. So the Ohis standard is stereo for receive audio from the radio. So there are separate left and right channels. If your radio outputs separate left and right signals, that will be preserved all the way through Ohis up to your headphones. Most radios are mono, and so with a mono, you're just going to get the same signal in both ears. The station console, the simple version of the station console, will probably not have any sort of pan control. I suppose it wouldn't be too hard to add. I don't know. I may look into that. It's probably not going to be a front panel accessible control, but it may be something that you could adjust internally with a trim pot. I would have to look into that because I'm running out of panel space on the way that I'm designing the UI in my head. And that's kind of a low on the list of, it's a low on the priority list of features. But that is certainly something that could be added in the future. And I am designing in my head a pro version of the station console that is going to be a whole lot of features. And it may end up just being entirely digital. Like the OHIS inputs may go straight into an audio codec and send an audio stream into a microcontroller or an FPGA and have all of the stuff done in there. If that's the case, then that kind of processing is, code. It's easy to add. But for the first one, it's all just going to be simple analog stuff. And it almost, if I do add the ability to pan an input from one side to the other, it's almost certainly not going to be a front panel control. Cool. Any other questions? I'll take this opportunity to point out that there is, in fact, a coupon code that is active through the end of August to get 10% off your entire order at electronics.halibut.com if you are interested in buying some of this stuff. Early Bird 10. So use the coupon code HHI Early Bird 10, which I just pasted into the chat group. That will work through the end of August. Like I said, the User Pro and the Radio Pros are on pre-order right now. All of the parts except for one are at the manufacturer and they're ready to go, but they're just waiting on some cases from Hammond. And the delivery date on those is supposed to be early September. It's closer to mid-September. Once those are delivered, assuming they're delivered on time, I have some work I need to do on the plastic cases. I need to route some holes in them and then send them off to the manufacturer up in Monterey. and then like a week or two after that, they will be ready to ship out. So I think my October 2023 is a very likely date to actually hit, assuming Hammond doesn't come back and screw me on delivery dates. Everything else is there and ready to go and just waiting on this one more part. So October 2023 will be a very, very likely delivery date to hit.
Nice. So I'm assuming since I've downloaded this off I forget where I got it from, but you have no problems with us sharing this around the group and posting it to our groups.io.
Absolutely. Yeah. Share as far and wide as you can. I want everyone to hear about this and hopefully get excited about it. And if you guys have any contacts in other EOC organizations or Aries organizations where you think they would benefit from this, send it off to them. Tell them that I am up for talking to any group over Zoom. And if you're within driving distance of San Luis Obispo, California, I may even show up in person.
I'll be in Paso in October.
There you go. It's a nice time to be in Paso. Dang.
Niece is getting married.
Oh, very cool.
All right, Mark.
All right.
Well, thank you very much. This is, I know I've been looking forward to this. I've heard some of this before, and this may be the first time I heard it in its entirety and had an opportunity to ask questions. I hope everybody else enjoyed it as much as I did.
Yeah, thank you. Thank you for having me, giving me the opportunity. You can, if you do end up with any questions after the fact, you can email me, mark@halibut.com or mark@electronics.halibut.com if you want it to land in the correct mailbox. So email works there, mark@halibut.com, or there's a contact us page on electronics.halibut.com, which is my website for all of this stuff. Happy to answer any questions. Happy to help you design your own products that compete with mine. Let's get some adoption out there. And if y'all think this is as awesome and as I do, then let's make this happen.
Yeah, this was one of those things when I heard you talking about it, it just clicked, and it's like, yeah, that makes perfect sense.
Yeah.
So
I've talked to some of the big hardware manufacturers about it at Hamvention this year, and the response I got pretty universally was, I refer to it as optimistic skepticism, which is, that's really cool. That should totally happen. I don't think it'll ever happen. And I'm like, yeah, I know. You and everybody else. Let's go get some adoption. Let's get some adapters out there. And the two companies that I spoke to, one was to the CTO and the other one was to the CEO. And they both said, we're not going to be the first ones to put this on, but if it does start getting traction, we absolutely will add this to our devices.
Inertia is really hard to fight. And
it is. It is. And from the good point, or from, in my opinion, I'm not trying to replace anything. I'm not saying that ICOM and Yaesu and Kenwood and Flex and Elecraft should remove the microphone ports they already have, and eliminate the ecosystem of products they've already sold and already developed and all of that fun stuff. Leave your existing ports there. Just add this OHIS port on the front or the back and let people use the standard as well. You've already got the accessory port or the data port that has like the direct discriminator output for doing 9600 baud or for connecting to a computer, right? You've already added more ways of getting audio in and out of your computer. So don't tell me that you can't. Of course you can. It's just a choice to do so, but you don't have to replace your existing one. You can add an OHIS port to your radio, and then you get the best of all worlds. So that's my opinion.
Makes sense.
Yeah.
All right. Well, thanks.
Cool.
Yeah, if you're welcome to stick around, and if anybody has any questions for Mark right now before we move on, do a little more club business before we close up. if you think of something, you can shoot him at his email. He may hang out here for a little bit. We're going to conduct a little more club business and just go around the table.
Sounds good.
And yeah, I borrowed from the Ham Radio Workbench. Usually when I'm running the net, I always go around and ask everybody what's on their workbench.
I have been super impressed to see how far the What's on Your Workbench has traveled. That has made me so happy. George and Jeremy started that back in the early days. So I'm not even involved in it, but I hear it on other podcasts. I see people talking about it on YouTube channels and things. That just makes me so happy.
So everybody,
yes, please, by all means.
Everybody who's heard me say what's on your workbench, this is where I got it from.
Ham Radio Workbench. That's a George and Jeremy thing from the early days. Yeah, so that's great.
All right, thanks again, Mark.
All right, thank you.
So moving on, treasurer. Are you here?